Hey, welcome back to the lecture, and in this lecture let's understand about how we can talk to the I2C engine of the AM335X SoC by using our application. So why I am covering I2C is because, as you know, the MPU 6050 actually communicate with the I2C interface. So having a little knowledge about the I2C engine would be beneficial. Okay, great. In the TRM, so I just opened my TRM. Okay, and here if you click on I2C section, okay, this introduction section explains various feature of the I2C. Please go through this document if you are doing any projects on I2C to understand its various features. And in the integration section here, you can see that how you can use I2C to communicate with the various I2C devices. Okay, so and here it says that this device, that means the AM335X device, includes 3 instantiations of the I2C module. So that means there are 3 I2C controllers are available for your use. Okay, the I2C controller 0, the I2C controller 1, and the I2C controller 2. Okay, so now in the operating system, okay, I mean the Debian operating system, if you go to the dev directory, okay, and if you just do ls-l I2C star, okay, you will see that there are 3 I2C device files, okay, belongs to 3 different controllers, okay, of the SoC. Okay, so that means the dev I2C 0, I2C 1, and I2C 2, these are software representations of these engines present in the AM335 SoC. That means these are the device files by which you can talk to these controllers. Okay, you can initialize these controllers, so you can work with these controllers from the software end, and these interfaces are actually enumerated by the OMAP I2C driver present in the kernel. Okay, our application actually uses these device files to talk to these controllers. Okay, just go to dev and check whether your operating system indeed displaying, okay, these 3 devices. Okay, that is I2C 0, I2C 1, and I2C 2. Now you may have the question where exactly we are going to connect our MPU 6050 sensor, okay, whether it is to controller 0, controller 1, or controller 2. So before answering that question, you have to open your Beaglebone's expansion header details to see what are the I2C pins are actually available. Okay, so based on that we can decide, okay, which controller we are going to use. Okay, so now let's go to the SRM document to see what are the I2C pins are actually available. Okay, all right, so this is our expansion header, and search for I2C pins in this table. Okay, let me just search for I2C here. Okay, and when I click next, okay, it is directly taking me to P9 header. Okay, so that means no I2C pins are actually available on the P8 expansion header. Okay, so you can see it is directly taking me to P9 header. Okay, and here you can see that the pin number 17 and 18 of the expansion header P9 are actually meant for I2C 1 controller. Okay, and 1920, okay, they are used for I2C 2. Okay, so only I2C 1 and I2C 2 controller pins are actually available on the expansion header. Okay, so this information is not sufficient, okay, because the pin 17 and 18, they act as a I2C pins, okay, only when, okay, you program them into mode 2. Okay, so if 17 and 18, if they are not in mode 2, then you cannot use it as a I2C pins, okay, unless you change its mode by using device tree overlays or by some other means, okay. And similarly, the 19 and 20, they cannot be used as a I2C2 pins unless its mode is how much? 3. Okay, so that means first you have to verify, okay, whether their mode is really for I2C or not. So for that you have to take the help of your sysfs pin control location. So first open this document which I shared, okay, header pins map. Okay, this actually maps your expansion header pin to software pin number, and now we want to see what is 17 and 18. Okay, so 17 and 18, sorry, let's go to P9. Okay, 17 and 18. Okay, 17 is 87 and 86. Okay, so let's go to now sysfs directory under this kernel debug pin control, right? Then go to, just do ls here and go to this pin muxing directory. Okay, and here what you have to do, cat pins, right? Just do cat pins and it will open up various pin details, and 17 is 87, so search for 87 here, and the last 3 bits actually 7. That means 17 is not in I2C mode. Okay, its mode is already changed to 7. That means 17 and 18, they are acting as a GPIOs. Okay, unless you change that by using device tree overlays or by some other means, you cannot use it. Okay, so you can confirm by checking pin 18, also 86. Okay, 86, no, you cannot use, it is also 37. So the last 3 bits are 7. Okay, so now that means I cannot use 17 and 18. Now let's try our luck for 19. Okay, 19 is 95, and let's check 95 here, and we are lucky. The 95 is in mode 3. That means, okay, mode 3, this is mode 3. Okay, that is, yes, it is in I2C mode. I hope you get it. Okay, so I have to connect my I2C, I mean the MPU 6050 sensor to I2C2 device. Great, so now let's move forward.